Hi, my name is Steve Rahi. I am a premier field engineer specializing in system-centered technologies. Today's discussion will be the beginning of a series specifically focused on detailing and describing operating system deployment in Configuration Manager 2012. Today's session will be the very first session in this series that I envision to run maybe 15 parts, maybe more, not sure yet, to kind of talk about this topic. We're going to deal with the introduction and basics today, really kind of setting some of the stage of where we're going, understanding the terms, that kind of thing, right? This will be an end-to-end series. The idea of this is to bring someone from zero knowledge of OSD through advanced knowledge and experience with OSD. So here we're starting with the very beginning concepts, right? You will see as we go through some of these topics, multiple times you will see me go into the console and maybe talk about certain areas, and that's really kind of by design. The idea of repetition helps with learning. That's certainly true for me, and certainly true with OSD. So we'll spend some time doing that. Specific sections in this discussion that we'll cover is kind of a review of what is OSD, right? Why choose OSD for your imaging solution? We'll spend some time in OSD concepts, defining terms, talk about the flexibility of OSD, and then finally we will get into the console and do a very brief tour of the components of OSD that we'll be working with in future sessions. So let's dive right in. So the first question, why OSD? There are a number of other imaging solutions out there. Why would one choose OSD versus some of the other, right? Well, there's a few reasons. You'll find even more as we go along. I'm sorry, what is OSD? I went ahead of myself. What is OSD? So my experience is that when folks start to really pull the covers back, even internally, on OSD, it's a bit daunting, right? About understanding what this beast really is. When you boil it down to its very basic components, OSD is all about automating and simplifying the process of operating system installation. If you look at it, everything OSD does can frankly be done manually, but OSD brings a lot of really cool automation, shortcuts, if you will, to allow the various tools that are leveraged as part of an operating system deployment to be done so, to be leveraged in a manner that is more straightforward. So that's the second point. If you look at it, OSD really is a combination of the Windows deployment tools, the automated deployment kits and such that are available for every version of Windows, plus the goodness that Configuration Manager can bring, right? Made together in a single package to be able to automate the process very effectively of deploying operating systems. So, and then finally, OSD specifically is designed for image deployment. It is not just for image deployment. There are lots and lots of people that use it for just routine tasks where specific order of operation and predictability is required. Certainly works very well there. We're going to focus on OSD as an image deployment solution, at least for the very many first few sessions. We will have some discussion about OSD outside of an imaging scenario as we progress in the series, but just know that's coming. But for now, we're going to focus on its design for image deployment. All right, so now back to the slide that I got to a bit prematurely. So in terms of the why of OSD, right, there's a number of different imaging solutions that could be brought to bear. Why would OSD be one of interest? Well, I'm going to actually start with the very bottom line and finish with the very bottom line that's highlighted in yellow. I highlight in yellow just because I'll just tell you, this is my opinion. You may hear different opinions from different people. That's fine. There are as many opinions maybe about OSD, the way to use it, and different things as there are consultants. Probably not that many. I think this opinion would probably be shared by most people, but it is my opinion, right? And that is that if you have OSD in your environment, it should absolutely, hands down, without reservation, be considered as the primary imaging solution. You may not choose it, and there may be some scenarios where you don't leverage it, right? But the vast majority of the time, it should win the discussion as the chief imaging solution for an environment. Whether, and you'll hear me say this a couple of times, whether you have physical machines or virtual machines, whether you have workstations or servers, OSD is the most flexible imaging platform that I've ever come across, right? And most powerful at the same time. And with all that power, the most simplistic, right? Okay, so I'll come back to that as we wrap up this section of the discussion. So in terms of why OSD, let's go back to the top. So to understand the goodness of OSD really leads us to a discussion of how OSD is different. And the way to describe that is through the imaging approach that you take. So those terms are thick versus thin imaging. So if you think back over the years in which imaging has come to the point it is now, we started with a product like Ghost, and there's other products, there's PowerQuest and different things, but Ghost is kind of the hallmark product, if you will, or the mostly known product. And if you think of what Ghost does, it lines up exactly with this approach called thick imaging. So with Ghost, you would build a reference machine that has all of the different software in place that you might want to replicate out to new machines that are built. And after you build that reference machine, you would capture it. It would be in a file. And then if you need to deploy new machines, you would go ahead and deploy that file. Works great. Nothing wrong with Ghost. It works for what it is. But there's some challenges with the thick image approach, right? And a few of them, maybe not hitting them all. So in that process of building the reference machine, in capturing it off, right, in redeploying it, there's a few things that are implied, right? And the first one is that there's a technician that is actually doing the work to build these reference machines, to tweak these reference machines, to recapture these reference machines, right? Also implied in that is, since we're capturing the entire machine built to standard, you're going to end up with a library of images that need to be chosen for deployment and maintained, right? So maybe you have an environment where you have a build that's specific for your HR department, a build that's specific for your IT department, a build that's specific for your knowledge workers, a build that's specific for, and we go on and on. Well, each one of those would be an image that you would need to build the reference, maintain it, whatever. So if you, as an example, just put Office in that base machine, in that base image, and a change comes out to Office, maybe a service pack, a cumulative update, new version, whatever, you're in the business of having to mount every single one of those images, make the change that you need to make, and then recapture every single one of those images. It's a very labor-intensive process, and it's a human process, which means there can be mistakes that are injected into the process, even inadvertently, right? So if you were to take 3 really skilled senior engineers and put them around the table with the same build document, I often ask the question, what is the chance that if they each followed that build document to the letter, that they would end up having the exact same machine at the end? Chances are there would probably be some difference. It's not an intentional difference. Maybe it's a tiny little insignificant difference, but the reality is it would be different, maybe, from the standard image that's being described by the build document. If we can bring automation to the process of handling our image builds, even our reference machines, whatever, it will take human difference out of the equation, right? And free up human time to have to keep dealing with these images. So that's one end of the spectrum. The other end of the spectrum is this thing called thin imaging, and that's where OSD really starts to show its power, right? So thin imaging describes a scenario where the image that is deployed is the most basic, plain, vanilla image that can possibly be built, right? The nirvana of this is that the image that you're deploying is really nothing more than the very base operating system. And any customization that needs to be added to that operating system, that's all done on the fly, right? So you might still have a need to build a specific set of instructions and build a machine a certain way for HR or for your knowledge workers or for whoever, but instead of having to maintain a library of 10, 15 images, you instead automate the process through OSD, a process called task sequencing, which I'll show you that very briefly as we end up the presentation. Spend a lot more time in it. that will uniquely allow you to build that image in a custom way starting from the same base, right? And this moves you out of the process of maintaining the image into the process of automation, maintaining, building, taking care of the automation, which is, to me, a far more interesting world to be in, right? It also, as I mentioned, removes the human error. Okay. So then that's the thin imaging, right? And then there's the third approach, which is a hybrid of the two, where you just can't get away, either because of business needs or because of comfort level, from putting some things in the base image, right? Maybe, a very common one is that every system in the environment leverages Office, so the desire is to put Office into every single image and just deploy it that way. There's, perceived time advantages, which I'll hit on that one in just a minute. The reality is we can actually cover that scenario effectively in OSD, right? The biggest challenge with that is human error on the thick image side. If you are in a place where you must do hybrids, and I really don't like to see hybrids. I think there's a lot of argument against even having hybrids, which I'll get to in a minute. But if you have to do that, you can still bring the automation of OSD to bear on that scenario so that you avoid the human error and you're not managing the image, you're managing the imaging process, which is ultimately where we want to be. Right? And again, that's enough for that right now. We'll see that more as we go along, right? But let's talk about one more item that oftentimes comes up when we talk about thick versus thin imaging, and that is speed. Well, we choose thick imaging because it's far faster to deploy a thick image with everything fully configured than it is to deploy a thin image that is configured on the fly. Hear that a lot, right? Well, let's put some numbers on it and let's talk about it for a minute. Let's just assume that to deploy a thick image that contains every single thing that you need for a given scenario, maybe it takes an hour. Again, just putting some numbers. And then let's say that to deploy that same image in a thin fashion where you're customizing it on the fly takes 2 hours, double the time. I don't believe it will. In fact, I think we can oftentimes get to very close to parity between image time in thick versus thin. However, let's say for the sake of argument, it takes twice as long. The question you have to ask yourself, is that extra time incurred for building the image a sufficient justification to pitch the goodness of thin imaging, instead go to thick imaging? Now, understand, OSD can handle both. You can absolutely deploy a thick image with OSD. You can absolutely deploy a thin image with OSD. You can absolutely deploy a hybrid image with OSD. But the question is, what are you going to get out of OSD? And if you go the thin route, you're going to get a whole lot more. Maybe it'll cost you more time. Again, I don't think so, but let's just go with our example. Say it cost you twice as long, 2 hours instead of 1. What advantages do you get for that extra time spent? If you are building the automation to customize your deployments, all of a sudden you have a very fully self-documented imaging process. If it is not in the automation, it's not going to happen, right? If you can start automation and point it to a machine, now you don't have to have a technician there. Maybe you still do, but you don't have to have a technician there to take care of anything. It's built the way it needs to be built from the very beginning, right? As you go to maintain these images and maintain the system, you can do that in a way that is maintaining the automation, not having to keep cracking open these images and resealing these images, right? So some pretty strong arguments of what you can get out of thin imaging, even if it takes longer, which again, I don't think it does all the time. You can engineer it in a way that it doesn't. Okay, so enough about that. Thick versus thin imaging, very clear contrast. OSD can handle both. The real power of OSD you start to see when we get to the thin imaging side. Okay, we'll dig into that more as we go along in the series. Next item, the WIM file. So OSD is fundamentally different in terms of the WIM file itself. Windows imaging format file, right? So just contrasting to something like Ghost or a Ghost-like product. If you have that kind of technology, basically when you take an image of the machine, it is doing a sector-by-sector copy of the hard drive. Well, that works, no problem. But the difference is, if you were to take a Ghost image, maybe you build your reference machine, 80 gig hard drive. Maybe on that hard drive, 20 gig of space is occupied by the content you've deployed. 60 gig is free. So you have that 80 gig hard drive, the system's built, ready to be imaged. You run Ghost, it images, and puts that into a file. Well, if you then take that image and try to deploy it to a system that has a 60 gig hard drive, plenty of space for the content, only 20 gig of content, that will absolutely fail because it is a sector by sector copy. Ghost expects a system that has at least the same size hard drive as what was used for capturing, right? In the WIM format, it's a file by file copy. So in that scenario, it would absolutely be possible to take an 80 gig hard drive with 20 gig space consumed, capture that into a WIM. We're only scraping the content that's used, so it's faster, right? Likely. And then you can take that same WIM and deploy it back out even to a 30 gig hard drive, 25 gig hard drive. As long as you have the space necessary for the content, you're good. Right? Other things that a WIM brings to you, single instance storage. So you can actually store more than one image inside a WIM. If you do that, then you're going to want to have the ability to store the files that are in common one time. So if you have, for example, 3 versions of Windows 8 in a WIM for some reason, most people don't, but if you do, then the DLLs that are in common between all of the systems will only be stored one time, making the WIM file smaller. Right? A compelling reason also, I like this one a lot, and you'll see it used as we go through the series, WIMs lend themselves to offline servicing. Well, what does that mean? Right? Well, just take our hybrid approach that we talked about earlier. Maybe you're in a hybrid approach, meaning that you're not really concerned about having Office on that image, but you do want to make sure that image is up to date with patches as much as possible. So that is kind of a hybrid imaging scenario. With the WIM file, with OSD, with ConfigMgr 2012, you can actually, in the console, manage adding patches to a WIM through the processes of offline maintenance, right? All of that offline maintenance is facilitated through the toolkits provided by the Windows Deployment Automated Deployment Kit. We can take advantage of it automatically for you in OSD to do things like add patches, inject patches into an image that's not mounted. It's just a WIM file. Well, in addition to that, you could actually go through the process. It's a manual process, but you could use the tools like DISM, right? DISM is a tool in the Automated Deployment Kit to inject things like registry keys or software, right, directly into the WIM without ever having to mount it. Huge advantage there for maintenance, right? And there's others, right? Any way you slice it, you do want to get to a WIM because that is what is deployed by OSD, is the WIM itself. There's multiple places you can obtain the WIM. You can create it, capture it. You can actually use the install.wim from the source media. We'll get into that when we talk about strategies for building your image in future sessions. But you do need to get to a WIM. All right. So that's the WIM file. And there's probably more to it, and I'm just skipping over some of it. That's fine. OSD, the ultimate of flexibility, right? So with OSD, you can build the most basic image, just basically capture the image and deploy it out without any bells and whistles. Or you can get incredibly advanced, adding all sorts of logical flow, choices that will be made, decisions what to do in the imaging process. All of that can be done. We'll get there and we'll show it to you, but that's all possible, right? Also, the various imaging scenarios that you'll encounter. So it could be that, kind of like going back to the discussion of thick imaging, there you might have 10, 15 images. With OSD, we offer a full custom deployment end-to-end. Ultimately, the end result of that is you could end up with one task sequence that is engineered in such a way that it covers all of those 10 or 15 scenarios all within the one task sequence, and you end up managing just one image. Right? Very possible. Right? Very flexible. You can also, like I said, deal with servers and workstations. It doesn't matter. You can deal with physical and virtual, just the same. On the server side, if you want to configure the hardware, there's partners, OEM partners, that have toolkits that plug into OSD that will let you configure the RAID arrays and different things on systems as a part of imaging, right? So definite goodness there. So I kind of summarize all of this in the idea of the OSD onion. Whenever I think of an OSD, I think of an onion. You see a picture of the onion, you know what it looks like. It is what it is. But then as you start to pull back the covers and peel the onion, you see there's different layers that go all the way to the core. Well, that's exactly the same thing for OSD. As you see OSD, you see this imaging solution that will let you deploy images. That's absolutely true. But as you pull back the covers on it, you start to see the flexibility, the capability of OSD can really lead you down a path to some really cool, flexible, capable solutions for imaging, right? And that's why I believe, back to the point in yellow, if you have OSD, you've got to consider it as the top contender for imaging in your environment, right? It brings together all of the goodness of ConfigMgr, the scheduling, the maintenance windows, the reporting, all of those things with the goodness of OSD and the imaging that comes, right? Head and shoulders above any other product, even MDT. I love MDT. MDT is a great product. If you have OSD in the environment, OSD should most often be the winner in the choice for imaging. Not that MDT is not a great option. It is. If you don't have OSD, go with MDT. Please, it is the best option out there. If you have OSD, please leverage MDT. It works alongside OSD very well and brings some great things to OSD that OSD natively doesn't have right now, right? So the partnership of OSD and MDT is a great thing, but if you have OSD, it should be in the driver's seat as far as imaging, and MDT should be supplemental, right? Okay. Cool. So we've beat that to death. Let's move on. So in terms of the OSD concepts and terms, right? So there are several different build approaches that need to be handled by any imaging solution. OSD handles these very elegantly. At the top level, there's two big concepts that you have to bring to bear. One is bare metal imaging, imaging a system that does not have an OS, maybe one coming from the OEM, and you need to put an operating system on it and put it in production. That's one scenario. And that could also be systems that are being repurposed. Maybe there is an operating system on there. You just don't want to consider that operating system. You want to wipe it out and treat it as if it's bare metal. The other scenario is a reimage scenario, where you might have machines out in the field deployed, and you're trying to reimage them to a standard version of the existing OS they have. Maybe you are moving them from Windows XP to Windows 7 or Windows 8, whatever, 7 to 8, transitioning between OSs. Maybe it's a scenario where the hardware is being replaced and you want to preserve the settings on the system that currently exist and move them to the new system, right? All of those are reimage scenarios. We handle all of those scenarios very effectively. So with bare metal, the distinction here is bare metal, there's really four ways to engage an imaging process for bare metal. A very popular one is to use PXE, the PXE boot option on these systems to boot to a Windows deployment server and start to deploy the image that way, right? Don't have to use PXE. You can use boot media that's on a CD or DVD or USB stick, whatever. You can do that. You can also do offline builds, completely offline, where there is no network connectivity at all, or very flaky network connectivity. We handle that. There's also a thing called pre-stage content. I won't get into that right now, or pre-stage media. And we handle that effectively as well. We'll talk about that down further in the series, right? Whichever pathway you choose, and this applies to reimage too, I'll get to this in a minute, but whichever pathway you choose for bare metal, whether it's PXE, whether it's boot media, whether it's offline, right, or whether it's pre-staged, what you need to do first is get into the Windows PE environment. Because in the Windows PE environment is where we're going to be doing our imaging, right? Windows PE is this reduced size version of Windows that runs totally in RAM. While it's in RAM, we have full access to the hard drives. We can manipulate those hard drives, format, partition, load files onto them, whatever we need to. And that's where imaging takes place, in Windows PE all the time, regardless of the entry choice, the entry portal to imaging. All portals lead to Windows PE, right, including reimage. So in reimage, the way imaging is initiated here is through a deployment to a client, a ConfigMgr client. So once that client receives the operating system deployment, you can initiate that deployment from the running OS, right? That gives us opportunity to preserve user settings and different things as we transition to the OS that's going to be installed. But even there, you will see in the reimage process, as we get further into the series when we do that, that very quickly one of the first things we'll do is capture any data we need, then we reboot the system and load Windows PE. The only difference in bare metal and reimage is bare metal always takes place without a running OS or without considering the OS that might be there. Reimage takes place from the running OS, reboots into Windows PE, right? All of these get to Windows PE. Windows PE is where the imaging takes place. Here's another little tidbit just to understand. When you watch the process of imaging, when end users see what's happening on their machine in terms of imaging, the best scenario is that a user starts maybe with XP these days. As I'm recording this is a hot topic. XP as they're going to Windows 7. The user experience that they would like to have is that all the settings, the IE favorites and the desktop settings and Word settings and whatever settings that they've configured on their system get saved off, preserved, and then they get to Windows 7, all those settings are restored, and they look just like they did whenever they were in Windows XP, except it's a new operating system. To a user, that process would look like an upgrade from Windows XP to Windows 7. In OSD, in no case do we ever upgrade an operating system. Every time an operating system is deployed, it is a fresh load onto hard disks that have been wiped clean. But the way that we can do the imaging approach will make it appear as if it's an upgrade, if it's done right? And that's what you want in those cases. All right, cool. So let's move on. So in terms of OSD flexibility, just a couple more terms to throw your way. So there's the concept in imaging of zero touch and light touch. OSD was designed to be a total zero touch solution, meaning that there's no need for technicians to be attending whenever there's an OSD image taking place. So you could have imaging take place. There's that process is totally driven by the ConfigMgr system. No need for a technician to intervene at all. Totally hands off. In fact, when OSD was first released, it was really hard to break into the system to have any interaction with it at all, right? Zero touch. But there are some scenarios where customers would like to have at least a minimum amount of touch, light touch, and so there are ways in which we can get in better today and more flexible today in 2012 than ever before. Get in and maybe launch an HTA or have some interaction as the imaging process continues. You can do that. It's really cool when you can get to a zero-touch world, but if you need the experience of light touch, we can handle that for you too. Right? Then there's the idea of unknown versus known computers. Right? To put it simply, and you'll see this as we progress along, an unknown computer is one that has never been in the ConfigMgr environment before, right? Whereas a known computer is one that has been an active ConfigMgr client in the past, right? So an unknown scenario, a very common one, is if you receive a shipment of systems from your OEM and you need to plug those systems into the network and immediately start to image them. We can handle that scenario either in an unknown or a known situation, but it's very common in that case for folks to choose the unknown because those systems are not yet known in the environment. They're going to become known through imaging. The known scenario means that, again, they're imported in some way into the ConfigMgr database already, so they're known that way, and we can image them because we're already known. There's some definite advantages to the known scenario as well in terms of carving up deployments and such. Again, we'll get to that later, but that's what that means. All right, cool. So that takes us to the components of OSD, and this is where we'll pull in the console, kind of walk through some things and talk about how this lays out, right? So Really three nodes that I want to hit in the Config Manager console. First, there's some site systems that can come to play with OSD. We'll hit those. Then we'll move to the reports. There's some reporting categories that are interesting for OSD and task sequencing, and then we'll end up our time in the software library just kind of walking through some of those nodes. So let me pull in the console and we'll spend that time. Okay, so here we are in the administration node. So in OSD, there are two site systems that you may want to consider. Neither one of these are necessary to do imaging, but they are conveniences that many organizations use. Right? The first is this thing called a pixie point. So every distribution point in Config Manager 2012 is optionally a pixie point. Right? Every full distribution point is optionally a pixie point. So if you don't want it to be a pixie point, great, don't enable it. But if you do, go ahead and enable it here. And the distribution point will go ahead and configure itself as a pixie point. So what is a pixie point really? Well, just like take software update point. Software update point really is just Config Manager code laying over the top of the WSUS server and interacting with the WSUS server. The pixie point is the same way, but for the WDS server, right? Pixie points require WDS, and we leverage the binaries and things that are in WDS to get the job of pixie booting done for OSD, right? Many environments use pixie. You absolutely don't need pixie to do imaging, but it's a great convenience in many environments, and this is where you set it up. Another site system role that you could choose, and we'll dig into this a bit more later, is this thing called a state migration point, right? Again, not required. A state migration point, very simply, is this. In terms of the term state may be a bit confusing because we talk about state in Config Manager in terms of state messages. That's not what this is. State in this context means user state. So that scenario I described, the reimage, where you might want to capture off user state in the beginning and then restore that user state, meaning IE favorites or desktop settings or whatever, restore that to the system after the new image is deployed. That's the function that the user state migration point fulfills. This is a separate site system. Think of it as a glorified file share, where as we capture the user state, we will put it on the user state migration point. When we need it to restore, we will retrieve it from the state migration point and put it back on the system. If you're dealing with user state, this is an option. It is not a requirement. There's other ways to deal with user state, kind of like hard linking and things that we'll talk about when we get specifically to the section of the series that focuses on that. But that's what this is, right? Okay. Beyond that, we have some reports, kind of jumping to this, that are specific to our task sequence. So task sequence, just for terminology, you'll see it in a minute, is the real engine for deploying images in an environment. Okay? Not going to dig into it today. I'll show you a couple just quickly, but we'll dig into them later. Like with anything in Config Manager, you want the ability to report. So certainly for task sequences, we give you a number of reports that will help you check the deployment status, look at the various deployments, check the progress of an individual task sequence or all task sequences. As you'll see when we get to task sequences, task sequences are a series of steps. Those steps are numbered, right, internally, and we will tell you what step a given system's on or a given task sequence is in, what the result is, all that kind of thing in these reports. And then finally, references. So task sequences will reference content, packages, and applications and different things potentially as they run. So you'll be able to see all of the references that a task sequence needs as it runs. Any dependencies, another word for references, right? Okay. So that said, we get to the operating system node of the software library. And if we look at this, we'll just kind of go top down and talk about each of these nodes. Right? We'll take drivers and driver packages together. So in terms of drivers, again, this is something we'll touch on quickly. There will be a section where I talk about driver management philosophy in task sequencing in OSD. But the idea of driver management is this. We've all been, if we've dealt with imaging for any length of time, in scenarios where an image is deployed and then the system reboots, everything's fine, but you very quickly realize, oh, wait, there's no network drivers for this system, right? I need to go fix that. And then it's a pain because you don't have network access, so you can't really go easily download. You have to go to another system, get the files, move them over. You know the deal, right? So the driver sections of the OSD node really allow you to evaluate the machines in your environment, import all of the drivers for the various models that you have in your environment into the library. So when the image is deployed, we will have a source of drivers that are configured either specifically for a model of machine, or maybe we can leverage plug and play again. We'll dig into the details of that more as we get to the driver section. Suffice it to say, for now, we do a process that allows us to retrieve the drivers for given machines. So whenever we reboot into that system, the user doesn't experience lack of network connectivity, doesn't experience a screen that is the wrong size and weirdly shaped, doesn't experience the sound card not working, that kind of thing, right? It's a good user experience. Another section, and you can go import drivers all you want to from your OEMs and make sure that happens, right? Another section of the console is operating system images. So we talked about, and we'll show you in sessions coming up, that in order to deploy an image, it needs to be in a WIM format. That system, that image that you want to deploy, needs to be encapsulated in a WIM. Once you have that system in a WIM, you can import it into the console here just by selecting right-click, Add Operating System Image, right? And you'll see it here. So you'll see Windows 8 Enterprise is an image that I've imported. You can go to Images and see the details about it, right? And this image, this WIM, now that I've imported it, I can easily deploy out to any system I want to, right? So the question becomes, okay, how do you get the WIM? Well, that's the process of using potentially a reference machine or using the install.wim on the source media CD or whatever to get it. We'll get into that later. But this is where you actually import that WIM once created. You really need to have the WIM imported to be able to deploy it. There are some ways you could do it without it. The next section you could actually use for image deployment, but it's not typically done that way. To deploy a system is from the WIM, right? Okay, so that said, what is this operating system installers? If we have the WIMs, the images imported up here, what's an operating system installer? Well, so if you think, and you'll see this whenever we talk about, again, the section where we capture a machine, there is a process. So I told you about the hybrid, right? Where you might want to have a system that maybe all of them have Office embedded in the image just because you've decided to do that, but you want to take advantage of the automation and the reduction in human error that OSD can provide. The use of an operating system image, you could do it with WIMs too, but the use of an operating system image is specifically geared for that, right? Historically. With WIMs, you can do the exact same thing. Again, we'll talk about that more in detail. But the idea of an operating system installer, I meant to say, is that you will basically import the source files from your DVD or CD into ConfigMgr. In fact, if we go to Properties on this and look at the data source, let's go in here. You will specifically see, if you go mount one of the DVDs for Windows 8 Enterprise and look at it and explore, it will look exactly like this. Right? This is the contents exactly of the DVD that we import into ConfigMgr for use. And the way that we use this is in that scenario where you might want to use the source files to build your reference machine and then capture that reference machine into the WIM. Right? You won't understand this really well here, but suffice it to say, you could build a task sequence that builds your machine from bare metal using source files, then customizes it to add those things that you've decided must be in the root image like Office or whatever, and then captures it into a WIM at the end. The task sequence type that this is typically used in is called a build and capture task sequence. You can get really away from this by going to the WIM directly, but again, we'll get into that in the future sessions, right? And you'll see it, but that's what's here. So the boot images, These are, so we talked about in order to do imaging, ultimately you need to get into Windows PE. That's where the image is deployed. So you need a source for Windows PE to help you get there. That's what these boot images are. If you look at these boot images, you will see they are Windows PE, right? There's an x64 version, x86 version, and these are the Windows PE components that are tied to task sequences. Every task sequence has to have, every imaging task sequence has to have a boot image, right? And we'll have a section where we talk about the concepts of boot images and different things, but just to show you this Windows 8, if I go to Properties, you'll see that I'm linked here to a boot image, right? Okay. So then we come to task sequences. So task sequences are, the task sequence is the engine of OS deployment. I'll show this to you real quick. Again, we're not going to dig into it in any kind of detail at all right now, but a task sequence you create by pointing to the WIM that you want to deploy, and then we will create through the wizard a basic task sequence to allow you to deploy that WIM. This is a very basic task sequence. As you get advanced, your task sequences will grow. Some folks I've seen have task sequences up in the 450 step range, right? Not uncommon, not a big deal. It's a self-contained engine that will help you deploy in various scenarios. This is the most basic step. So you could use this to deploy a WIM, the Windows 8 WIM that it's referencing right now, right? It's just a step-by-step, a little bit more than that, but a step-by-step approach to take actions, and you can see what some of them are, right? We'll dig into the task sequence in sessions coming up, but this is what it is, right? And this governs the flow of installation. All right. And then lastly, we have the virtual hard disk node. So this is something, and I'm on R2 by the way, so not all of these things, some of the things I'll talk about, if you have a previous version of ConfigMgr, you might not have some of them like this. You would not have this prior to R2. Most of what I'm going to show you is consistent across versions, but there are some tweaks that were added in Service Pack 1, tweaks that were added in R2, right? Virtual hard disk, this is a really cool way to integrate between System Center products and integrate with Virtual Machine Manager. So for example, if you have, so I mentioned that OSD can be equally used for workstation and server, virtual and physical. So if you have a desire to run your OSD task sequence, maybe you've got an OSD task sequence configured to build a Windows Server 2008 R2 box, and you want to run your task sequence to build a VHD, right, that can then be deployed from your VMM library, Virtual Machine Manager library, to a Hyper-V host. That's what this allows, right? So you basically deploy your task sequence, and we build a VHD based on that task sequence, based on what you tell us to do, and then export that to the Virtual Machine Manager library that you can then leverage in that environment, right? So that's really it. I wanted to walk through the terminology, at least do some level setting in this first session. Maybe you see already the detail that we can go into and will go into, and we'll definitely do that. Again, I don't think we'll be able to do this whole discussion in less than 15 sessions, maybe more, right? But this is the first step to understand the basic terminology. So we'll wrap this discussion here, and we'll catch you on the next session. We'll start digging into the idea of reference images. So we'll see you then.